from Unit 5. So welcome to the Water Resources Engineering 2 and the last unit, Canal Falls and Canal Regulation Works. The topic that today we are taking up is cross drainage works, their types and selection. So what is this cross drainage work? A brief introduction of it. What are the various types of the cross drainage works? And how do we classify the aqueducts and siphon aqueducts? And what are the process through which a particular type of a cross drainage work can be selected? So these are the topics related to the cross drainage works. So as the meaning goes like, what is this cross drainage work? There may be two water conveyance systems which may be crossing each other. That is what a cross drainage. Two water conveyance systems crossing each other. For example, a drain is crossing the canal. Canal may be laid maybe from the upstream far away from the reservoir to the tail race. It may be moving. The canal may be moving. In between, there may be small streams, rivers, or drains which may be joining there, which may be crossing it. So you have just like a road crossing across a canal, you may have a bridge. So what is to be done here? Because both are two water conveyance systems. One is the drain stream or river, and the other is the canal. So if they are to cross like this, what type of structure is to be provided? This is what is called cross drainage work. A canal may be moving from the reservoir to the tail end, but in between it may come across several streams, rivers, or drains like this. So this is what a structure which is required to be provided under this crossings is called a cross drainage work. One of the best examples for the cross drainage work is the aqueduct. So in this picture you may see that the water is there at two levels. So this is the water and this is also water. So this is a canal which is laid and the drain is there at the bottom. Sometimes it may be rivers also, depending on the local conditions, local gradients of the canal and the ground levels of the stream. It may be rivers also. So in this case, you may note that the canal is flowing at the top and the drain is moving at the bottom. So this is the drain over which a canal is flowing. So the canal may be carrying, and it is useful like a good navigation system also. Okay. So basically, a bridge is constructed when a road is crossing a canal. When a road is crossing a canal, a bridge is constructed. Similarly, a cross drainage work will be constructed if a canal is crossing a drain or vice versa. A canal is crossing a drain or a drain is crossing a canal. We have to go for construction of a cross drainage work. So a cross drainage work is a structure which is constructed to carry a canal across a natural river, stream, or a drain. So in the initial reach of the canal, it is usually aligned as a contour canal because the canal starts from the reservoir. It would be like a contour canal at the initial reach of the canal. So in this reach, the canal has to cross number of natural drains or rivers, and the cross drainage works have to be provided. When the canal is aligned as a watershed canal, no cross drainage work will be necessary because if it is designed as a watershed canal, it will move along with that, and hence cross drainage work may not be necessary. The cross drainage work is usually a costly item and should be avoided as far as possible by proper alignment of the canal. In fact, when a road is crossing a canal, when you have to go for construction of a bridge with abutments, piers, that also is a costly affair, but it is inevitable. It is inevitable because the road has to cross necessarily the canal to reach from one bank to the other bank. So it is inevitable and it has to be spent. Whereas here, to the extent possible, if the cross drainage work is avoided, the total cost of the canal project would be cheaper, economical, convenient. So the cross drainage work is usually a costly item and should be avoided as far as possible by proper alignment of the canal. Here is a case where you may see how a cross drainage work can be avoided. One small example that is shown here is that. So you see this figure. In this figure, you have stream 1 and you have stream 2. Across this, there is a canal flow. The canal is flowing, crossing stream 1 at this junction, and same canal is crossing stream 2 at this junction, and the canal is moving. So since two streams are there and both the streams the canal is crossing, you need to provide a cross drainage work here and you need to provide another cross drainage work here. How to avoid the cross drainage work? If you see in the plan, the total system, the stream 1 is flowing like this, stream 2 is flowing like this. So both the streams are joining at one point here, and then it is moving as a stream. It is moving as a stream. So the confluence point of stream 1 and stream 2 is here. From this confluence point, both the streams join together and flowing like this. So instead of running a canal through these dotted lines which are shown in the figure, if you just have a diversion for the canal and take this canal in this direction, after this confluence point, if the canal is crossing, only one cross drainage work would be sufficient. So what you have done now, you have avoided one cross drainage work here. So for stream 1, one cross drainage work should be constructed. For stream 2, another CD work should be constructed. But if you divert this canal, and change the alignment of the canal, now we are able to reduce one cross drainage work, and based on these two, we are constructing only one cross drainage work. So this is how several methods are to be verified, checked in the field, how we can avoid the cross drainage work. So cross drainage work is avoided by diversion of the canal from a straight route to a dotted route. So this is a dotted route through which the canal originally is meant for flowing, where you have stream 1 and stream 2 join together, and one after the confluence point of the stream, if the canal is made to cross, only one CD work would be sufficient. This is how you need to look at how the CD works can be minimized. The cross drainage works can be minimized. Types of cross drainage works, depending upon the relative levels of the bed and water surface and the discharges of the canal and the river, the cross drainage works are classified. The first one is like cross drainage work carrying a canal over a drain. We have seen in the figure also that there could be a possibility that the canal may be moving up and the drain is flowing at the bottom, or the reverse also. So in this specific case where the cross drainage work could be provided, where you have a canal over a drain, then the structure which is constructed is called aqueduct or siphon aqueduct. In the other case, this is the CD work where the carrying drainage over the canal. Here canal over a drain, but here drainage over the canal. How do you fix all this? Whether canal is moving over the drain or drainage is moving over the canal. So this will be fixed only based on the general alignment of the canal with respect to the natural ground. Because for the canal, when you are aligning, you can't give a very steep slope. Similarly, you can't give very mild slope also. If you give too much of mild slope, water may not be flowing. If you give too much of steep slope, jump may be formed and it may be very difficult, like cost of excavation will be very high. So keeping these two minds, a canal alignment becomes a very big subject. And at places where it is crossing a drain, you need to provide different types of structures. For example, aqueduct or siphon aqueduct would be provided if the cross drainage were carrying a canal over a drain. If the drainage is carrying over the canal, then you have to provide the CD work, namely super passage or canal siphon. The third category is that the cross drainage works admitting drainage into the canal. So this is another typical thing. You have a canal flowing across a drain, and there is a possibility that you are allowing the water of the drainage into the canal directly. Drainage doesn't mean that it is a domestic drainage. It is a drainage area or the catchment area through which the stream or river may be flowing. So the structure that would be provided in such case would be like level crossing, inlet and outlet. In such cases, you can directly mix up the water from river water into the canal directly, or stream water into the canal, and so on. So you have now 6 different cases, like 1, 2, where the CD work is carrying canal over the drain. 3 and 4, super passage or canal siphon, where the CD work carrying drainage over the canal. And if both are admitting one into the other, then it is a level crossing or inlet and outlet. So there are 6 different types of structures for 3 different cases. Let us discuss them in detail. In the cases 1 and 2, the cross drainage work carrying in the cases 1 and 2, the cross drainage work carrying a canal over a drain. So in the figure you can see here that there is a drain and the canal is laid over the top. So when the bed level of the canal is above the high flood level of the drain, the drainage water flows freely under the canal, and the type of structure provided is called an aqueduct. You can see here, this is the stream. This is the stream, and here perpendicular to that, the canal is flowing. If you see the canal level and the HFL of the drain, HFL of the drain is much below the canal bed level. So in such cases, the structure that is provided is called aqueduct. You can see here how. So at the bottom, drain is flowing. This is HFL of the drain, high flood level of the drain. Over and above this high flood level, the bed level of the canal is there. Over and above the high flood level of the drain, the canal bed level is there. So this is the full supply level of the canal. So there is no intermingling, there is no movement of water under pressure in the drain, and hence there is a free flow. There is a free flow in the drain. Similarly, there is a free flow in the canal also, because it is built. The canal is laid over and above the high flood level of the drain, and the structure that is provided is called aqueduct. The structure that is provided is called aqueduct. You can see here. So at the bottom, high flood level for the drain or river, and over and above which the structure that is provided is the canal, and the bed level of the canal is above the bed level of the canal, that is this level is above the high flood level of the river. Then it is called aqueduct. It is called aqueduct. When the high flood level of the drain is above the bed level of the canal, while the bed level is below that of the canal, the drain is siphoned below the canal, and the structure is called siphon aqueduct. So what is happening here? In the earlier case, canal bed level and HFL of drain. Canal bed level and HFL of drain, if you see, the canal bed level is much above the HFL of the drain. So water is flowing freely in the drain, and the canal water is flowing at the top. The structure provided is called aqueduct. But here in this case, you have the canal bed level. You see the figure. You have the canal bed level below the HFL. So this is the HFL, high flood level of the drain, whereas this is the canal levels. So what is happening here? The water, though it has to flow up to this HFL, but at the point where this structure has come, it has to get siphoned and flow only beneath the canal. This is the canal trough, what we call it as the canal trough. So it has to be siphoned to flow under pressure beneath the canal bed level and reach to the downstream portion. This is what is called siphon aqueduct. Aqueduct, free flow, siphon aqueduct, flow under pressure. So the water surface level of the flood flow is depressed when it passes under the canal through the barrel. The bed of the drain is also depressed and provided with the puck-up flow. You can see here in this figure. One more figure is shown here for more clarity. So this is the HFL of the drain, which is above the bed level of the canal. This HFL of the drain is above the bed level of the canal. So at this structure, it is siphoned, allowed to flow only beneath the canal, and it will finally reach to the downstream portion of the stream. So pucka concrete floor is provided at the bottom also, and this canal trough also would be suitably designed to carry this canal water, having no mix-up of this river water with that. If the drop is of the order of 1 meter, a vertical drop may be provided on the upstream side, and an upslope of 1 in 5 is provided on the downstream side. So this is all about these slopes. Okay, this is slope. So a vertical drop will be provided you have a drop of about 1.5 meter, about of the order of 1 meter, where the drop is much higher. Sloping floors are provided on either side. In these structures, there is no possibility of providing an inspection road along the canal at the crossing. Next, case 3 and 4, where the cross drainage work carrying drainage over the canal is just a reverse case. For an aqueduct or a siphon aqueduct, you have seen that the drainage is at the bottom, the canal is at the top. Now it is reversed. When the full supply level of the canal is lower than the bed level of the drain, the structure provided at the crossing is called super passage. Please try to note down the term is super passage. So all these are the CD works, cross drainage works. But however, like aqueduct or siphon aqueduct could be provided when the canal bed level is at a higher level than the HFL of the drain. But if it is reversed, like FSL of the canal is lower than the bed level of the drain, then the structure provided is called the super passage. Here, the drainage water is taken through a trough supported on the piers, while the canal water flows below the drain with a sufficient freeboard at atmospheric pressure. So the structure is called super passage. You can see here, drain and canal are crossing. and the canal is moving at the bottom. The drain is taken at the top. So how do you fix whether drain has to come at the top or canal is to come at the top? This is based on the alignment and longitudinal slope and gradient that is provided for the canal. So in this case, this is the natural drain, whereas the canal is at the bottom. So if the canal has to move beneath the surface of this drain, the structure that is provided is called the super passage. So for the super passage, the full supply level of the canal is below the bed level of the drain. Below the bed level of the drain. So this is the bed level of the drain, and the canal is flowing here. The FSL, full supply level of the canal, is only up to this. So it allows free flow of the canal. It is not at all suppressed at any point or depressed at any point. It is a free flow of the canal. So the structure is called the super passage. When the full supply level of the canal is above the bed level of the drain, and the canal is siphoned below the drain, that means you are now once again looking like a siphon aqueduct, where you are trying to allow the water to flow beneath the drain under pressure, then it is called canal siphon. So here the canal bed is lowered and the canal water is taken through a barrel under the drain. The barrel in this case acts as an inverted siphon through which the canal water flows under pressure. So this is how the canal and drain alignments are. So you can see here a super passage where the full supply level of the canal is much below the bed level of the drain, much below the bed level of the drain. But in the other case, canal siphon or siphon, where you may see here the full supply level of the canal is here. The upstream and downstream full supply levels are here, whereas the bed level of the drain is below this full supply level, and hence the water is siphoned beneath the drain and flows under pressure to the downstream portion. Flows under pressure to the downstream portion. Okay, so that is called canal siphon or siphon. Fifth and sixth cases also, let us see. Cross drainage works admitting the drainage water into the canal. This is a separate case. In the earlier two cases or in the earlier four cases, we are not allowing the river water to join with the canal water or vice versa. We are not allowing. Both are taken separate, like a separate trough, as if the road is crossing a canal and so on. The road is crossing a canal and so on. But in this case, it is separate in the sense that the water which is flowing in the river is allowed to get mixed with the water which is flowing in the canal. So this may be achieved by providing a level crossing or inlet and outlet. Only inlet or inlet and outlet is a combination. Okay. So when the bed levels of the canal and drain are practically at the same level, usually a level crossing may be provided. So you have canal bed level and the bed level of the river, both are at the same level. Then we have to go for providing either a level crossing or inlet and outlet. You can see here, this is the level crossing which is provided to canal and a drain, and in this case, what is happening? The water which is flowing through the canal is allowed to get mixed with the water which is flowing in the canal, or water which is flowing in the canal. Only small point that needs to be understood at this juncture is that the canal discharge prior to this drain crossing, whatever is there, same canal discharge should be there after this crossing also. Similarly, whatever is the water flowing in the drain, same discharge should be there at the downstream portion also, for which we need to provide the regulators. So this regulation arrangement allows to see that only the requisite water in the canal has to flow to the downstream portion, and similarly, only the requisite water from the drain has to move to the downstream portion. Because both are at the same level, it's all equitable. Whatever amount of water that is coming through this junction should flow out only or to that extent. It should not be more or it should not be less. So this consists of construction of a weir across the drain just upstream of a canal, crossing with its crest at the full supply level of the canal, a distributed head regulator, and a cross regulator across the canal at the downstream junction with a weir. So we are providing a weir with a weir crest here, and a cross regulator, and a regulator here. All the three are required. With no water in the drain, the distributed head regulator is kept closed and the cross regulator is kept open so that the canal flow takes place directly without any interruption. Suppose if there is no water which is flowing in this drain, then what will happen? The water flowing in the canal should flow directly to the downstream portion. should flow directly to the downstream portion. So this will happen if you have this regulator closed. So close this regulator, allow all the water which is coming through this canal flows to the downstream portion. The regulator is open and the flow in the canal is maintained by the regulation of the cross regulator. Level crossings are specially suited to the crossings of large drains when the cost of the CD works are very, very high. If both are at the same level and construction of any other type of structure like aqueduct or siphon aqueduct is becoming very costly, then it would be preferable to go for this type of structure. Sixth one is inlet and outlet. A canal inlet is constructed when the cross drainage flow is small and its water may be absorbed into the canal without causing appreciable rise. In such case only we will be able to allow or to have the mixing up of the water. In the earlier case 5, if you see, water is getting mixed in the level crossing, but however the share of water in the canal, the share of water in the river are not reduced or increased, not changed. But whereas in this case a canal inlet is constructed when the cross drainage flow is small and its water may be absorbed into the canal without causing any appreciable rise. So if a small drain is crossing the canal, the discharge into the drain may be very minimal. It is not giving any appreciable rise in the water surface of the canal, then it is advisable to go for this inlet. That means you are providing an inlet from the drain directly connecting to the canal. So whatever water that is flowing through this canal, through this drain, joins into the canal and flows along with the canal. So however, we have to see that the water level is not much raised. If the canal is small and the rainwater admitted into the canal through this inlet is to be discharged through an outlet provided at a suitable site, then you have to provide inlet as well as outlet. Both the things have to be provided. So the inlet may be a pipe, or even you can see here in this figure like any other arrangement. So you have an inlet. So this is a drainage or a small stream, and this is the main canal flowing. So the discharge flowing through this canal is appreciable high as compared to the discharge of the river or the stream. In such case, simply provide a small inlet like a pipe and join to this canal. But only thing is, if the discharge through this drain is more, then it may lead to rise of water level in the downstream portion of the canal, may be leading to other complications of submergence in the downstream side. So to avoid that, this is possible only for small discharges of the drain. However, if the discharge of the drain is more and more, then you have to provide an outlet also at a suitable downstream location. So what will happen? Through this small inlet, the river water enters, allows to get mixed here in this canal, but at a convenient location, it will be let off by providing an outlet here. So this is the combination of inlet and outlet. So you have two cases here. One is providing only inlet. If the discharge is not appreciable, directly join it to the canal. If the discharge is more and it is required to be drawn out, then provide inlet as well as outlet. Only thing is, proper stream training works or river training works are to be provided to see that the water which is drawn from the canal here once again joins back to the stream somewhere at the downstream portion of the original drain. So this is how an inlet and outlet arrangement would be there. You can see here there is a canal and a small pipe is provided here. And this pipe carries the water from the drain and joins into the canal. So this is the inlet. How do we classify the aqueducts and the siphon aqueducts further? So we have now seen what are the various types of cross drainage works. We have seen that there are 3 specific cases over which the different levels of the canal with respect to the high flood level of the drain and bed level of the drain with respect to the full supply level of the canal, and both are at the same level. We have seen 6 different cases, 3 different cases of which 6 different structures have been proposed, like aqueduct, siphon aqueduct, and then super passage, canal siphon, and then level crossing, inlet and outlet. Okay, so these are all the structures which may be provided. Further, aqueducts and siphon aqueducts also can be further classified depending on the nature of the sites of the aqueducts or siphon aqueducts, they are classified to be into three types: type 1, type 2, type 3 aqueducts. What are these type 1, type 2, type 3? Let us see. Type 1 aqueduct or type 1 siphon aqueduct. Please note here, this R doesn't mean it is aqueduct or siphon aqueduct. No, it is not like that. Type 1 aqueduct or type 1 siphon aqueduct. Type 1 aqueduct or type 1 siphon aqueduct. So in these aqueducts, canal is taken over the drain along with the earthen banks with the complete slopes. The length of the canal or culvert through which the drain flows must be sufficient to carry the canal section and the banks with their slopes. Type 1 is usually adapted when the width of the drain is very small, usually less than 2.5 meters. Type 1 aqueduct would be suitable. However, the cost per unit length is maximum for the type 1 aqueducts or siphon aqueducts. Second case is type 2. In this type, canal with its front slopes and the top bits of the earthen banks are supported on a barrel of the drain, while the rear slopes of the canal and banks are replaced by masonry retaining walls. So the length of the drain culverts or barrels is reduced by horizontal length of the rear slopes of the canal banks. So this is usually adapted when the length of the drain aqueduct, when the width of the drain is about 2.5 to 16 meters. Less than 2.5 meters, the cost is maximum, go for type 1. Second is, if the width is about 2.5 to 16 meters, then go for the type 2 aqueduct or type 2 siphon aqueduct. Then type 3. Type 3 aqueduct or type 3 siphon aqueduct, in this type, earthen embankments of the canal are replaced by the masonry or concrete trough, and the sides of the trough are taken into the earthen bank through wing walls. So the canal will be flumed at that portion and the width of the canal will be reduced. So the contracting the canal waterway and length of the aqueduct is usually greater than 16 meters and the cost per unit length of the aqueduct in this case would be minimum. So you have type 1, type 2, type 3 broadly with respect to the length of the aqueduct or width of the river which is required to be provided, like 2.5 meters, less than 2.5 meters, between 2.5 to 16 meters and greater than 16 meters. How do you select a particular type of cross drainage work? Maybe a level crossing, maybe an aqueduct, maybe a super passage, and so on. How do we select? The relative size of the canal and the river which are being crossed is the main factor to be considered in the selection of type of the cross drainage work. In case of large river, lowering the bed level by a drop would be very costly. So if the amount of bed silt carried by the drain is large, there is a risk of choking up of the siphon due to silting, and this increases with the size of the river. Thus, on large rivers, as far as possible, aqueduct only should be provided. We need to provide the aqueduct on the large rivers, because if you are providing siphoning, there is a very possibility that there would be choking because of the continuous siltation which is coming up underneath or beneath this drain. So because there is continuous siltation which is coming up, there could be a problem that portion, the cross-section area available for flow, would be reduced. Finally, the discharge becomes less and upstream water level rises, leading to the failures of the structures. So only aqueduct should be provided where you have large rivers. As far as possible, try to provide the aqueducts only. So this is how the aqueduct would be provided. This may require heavy banked approaches on the canals towards the crossing. So this is so because the river cross section is wide in plains, and since the canal is to be brought to the crossing with its bed level above the high flood level, then the results in the banked approaches on either side. On the other hand, in a siphon aqueduct, since the canal bed is not clearly above the high flood level of the river, the relative difference between the canal and the river is much smaller, and heavy embankments are practically eliminated. Therefore, when a river is small compared to the canal, it is preferable to provide the siphon aqueduct. So the selection also depends on the relative levels of the bed and water surface levels on the canal and the drain. However, the relative differences can be suitably attended. Sometimes it may be required to change the alignment also. For example, in the figure, you may see here A to B1, maybe the initial level, A to B2, maybe the original proposed. It may be changed to A to B1 and then move, or A to B3 and move also. So this is how we start changing the alignment slightly. Probably the provision of the cross drainage work also would be accordingly change. So sites for location of the aqueduct, siphon aqueduct, and super passage where you are changing the alignments. In addition, the site of crossing, the choice also is affected by the other factors like canal alignment and what is the foundation that is required to be provided and what is the groundwater level and how the groundwater level is going to be increased or decreased by providing this canal at that location, and suitability of the soil for providing the embankment. All the time, no, whenever embankment is provided, it is necessary that only locally available material should be used. Thereby, the cost of the structure will come down drastically. If you start spending more and more on lead and lift, naturally the cost of the structure becomes high. So, what is the soil which is available? Whether it is suitable for making the embankment, that fact also should be considered. Whether you need to construct a structure at B1, B2, or B3. Similarly, at B1, if you want to construct, go for aqueduct. B2, maybe go for siphon aqueduct. B3, go for super passage. So this also will change. So whether you are going for what type of structure, where you are providing, and what is the foundation there, and what is the other cost parameters that are there, and how the groundwater is fluctuating, whether it is meeting the requirements at the site or not, all these things are also to be studied. Compared to aqueduct, super passage as a cross drainage work is inferior and should be avoided wherever practical. So to the extent possible, you have to go for constructing an aqueduct or a siphon aqueduct compared to the super passage or a canal siphon. Similarly, siphon aqueduct is superior to canal siphon. An inlet may be provided for a small drain when the bed level is in the bed level in the canal FSL or slightly higher. Trouble may be experienced if the drain carries heavy silt. We already seen choking takes place because the siltation is there. Choking takes place. The available cross-sectional area would be less. Discharge becomes less. On the upstream side, water level increases, leading to the failure of the structures. So, on the whole, the performance of the inlets and outlets are not very satisfactory. The selection of suitable type of aqueduct or siphon aqueduct from type 1, type 2, type 3 structures, how it depends. We have already seen which type of CD work. Among these CD works also, like aqueducts, whether you need to take first type 1 aqueduct, type 2 or type 3 aqueduct. How do we? The length of the culvert, length of aqueduct which is required to be provided, and the bank connections which are provided. All these are the parameters based on which you need to choose whether type 1, type 2 or type 3. In type 1, the barrel length is maximum. Therefore, the cost per unit length is maximum. Type 1 is economical where the length of the aqueduct is very, very small. Or width of the drain, which is equal to the length of the aqueduct, is small, then type 1 becomes economical. No bank connections are required for this type. Whereas in type 3, the barrel length is minimum and the cost of bank connections is maximum. So this is suitable where length of the aqueduct is large. So type 2 is adapted for, of course, the intermediate conditions. So this is how we have the cross drainage works. So in this session, we try to look at what is this cross drainage work and why should we provide a cross drainage work, what are the various types of cross drainage works, and what is a suitable site for the cross drainage work, and how do we select a particular type of cross drainage work for a given condition, and what are the various types of aqueducts like type 1, type 2, type 3, and what their suitability we have discussed. The design of this aqueduct or siphon aqueduct or canal siphon or super passage is once again a separate big subject which is being dealt in the subject design of hydraulic structures. That is an exclusive subject. Already I indicated you in the last class also. There will be 6 to 8 structures will be there, and only these 6 structures will be designed. And in the examination also, one question will be given, and you have to answer that question. 2 questions will be given, 1 question is to be answered. Like you need to make a design, you need to draw it also. So it becomes complete 3 hours. No, it is 4 hours paper, not 3 hours also. That